This is lesson 6.2 in Math 30-2, where again we're looking at exponential functions and we're looking at how the graph and the equation are related to each other, really continuing on from what we did in lesson 6.1. So here on this page, this is the activity that I mentioned that I usually do with students in the classroom. So we're actually going to skip past because we're not in the classroom. And we're going to pick up with question number 5 here on the second page of the notes. So here what we want to do is, without using a calculator, we want to match equations with graphs and then explain how we know that they match. So as we do each of these questions, there are two key features that I'm looking for. First of all, I'm going to ask, is the graph increasing or decreasing? And then I'm going to look at what is the y-intercept. So you'll remember back from the previous notes in 6.1, here my graph is going to increase as I go from left to right if my b value is greater than 1. If my b value is between 0 and 1, my graph will decrease as I go from left to right. So that's one feature. And then we observed down here that our a value tells us the y-intercept. So the y-intercept is the same as this a value in the equation up there. So we're going to use those pieces of information as we do this question. So question number 5. Let me start by looking at this b value. Here my b value is 0.2. That's between 0 and 1, which means my graph is going to be decreasing as I go from left to right. So I don't want increasing, I want decreasing. So it's not going to be A. It could be C, not going to be B, but it could be D. So I've narrowed it down to C or D as my options for question number 5. Then here I'm going to look at the y-intercept. So this is when x equals 0. So remember, if I have any base to an exponent of 0, that's just equal to 1. So 0.2 to the exponent 0 is 1, and the result is I just get this 3. So the 3 is my y-intercept. I look here. There I have a y-intercept of 3. I look here. There I have a y-intercept of 4. So C is going to be my correct answer for number 5. Okay, let me erase some of the writing up here. Those I'll leave. Let's look at number 6. I look at my base. My base is 3. That's bigger than 1, so my graph is not decreasing. My graph is increasing. So I'm looking at either A or B. Then I look at the y-intercept. Here I have an A value of 4. So I'm looking for a y-intercept of 4, but my graph is increasing. Well, here I had a y-intercept of 4, but the graph is decreasing. I don't want D. Here I have a y-intercept of 4, and my graph is increasing. Here I have a y-intercept of 2, so I don't want A. My answer will be B. Why don't you pause the video at this point, and you can do questions 7 and 8. All right, question number 7. My B value is between 0 and 1, which means my graph is increasing, not, I should say, it is decreasing. It's not increasing. So I'm looking for a graph that's decreasing, and I want this y-intercept of 4. So I look over here, decreasing, y-intercept of 4, and so D is my answer. We could get number 8 by just eliminating the other options, but again, let's think it through. So my B value bigger than 1, which means my graph is increasing, not decreasing. A value is 2, so that's my y-intercept. My y-intercept is 2, and it's a graph that's increasing. I look up here and I see option A. As I go from left to right, my graph increases, and I have the y-intercept of 2. So even without the process of elimination, I know that A is going to be the graph that matches with this equation. Well, let's go a step more difficult. Suppose I have these three graphs and I want to write an equation. So again, I want to think about an equation in the form y is equal to some number times a base to an exponent of x. So here's what we can do. I'm going to start by looking at my y-intercept, and that will be my a value. So for this one, I have a y-intercept at 1, so that tells me a is equal to 1. Next, I'm going to look at where x is positive 1 or negative 1, which one can I actually see fairly clearly? Well, here where x is negative 1, I don't know what this is exactly. Maybe a half, looks like it's slightly less than a half, but I don't want to be guessing. So here I'm going to look where x is positive 1, and so when x is positive 1, here I get a y value that's equal to 3. So it goes through this point where x is 1 and y is 3. So what do I know so far? Well, in my equation, y equals 1, I'm not going to write it in, times b to the exponent x. So my equation will look like this because I have an a value of 1. Now I have one point here, so I can enter this for x and y in this equation. So my y value is 3 when my x value is 1. Oh, well, if b to the 1 equals 3, that just means that b equals 3, which means my equation will be y equals 3 to the exponent x. Let's look at number 10. Again, I'll start with the y-intercept. Y-intercept is 1, so that tells me my a value is equal to 1 again. I look at positive 1. I don't know what the y value is there. I look at negative 1. Okay, negative 1, I get a y value of 3. So now it goes through this point, negative 1 comma 3, as an xy ordered pair. So again, I'll think of my equation in this form, y equals b to the x. Again, I'm not putting in an a value because I know my a is 1. So it's just 1 times b to the x. I don't need to write the 1. But I have this ordered pair. So remember, that's giving me an xy ordered pair here, and I can substitute those in. So y is equal to 3 when my x is a negative 1. So here we need to go back to those exponent rules and remember that, oh, when I have a negative exponent, that means I can take the reciprocal and write it with a positive exponent. So I'll come over here. This means that 3 is equal to 1 over b to the positive 1. Well, if I want to find out my b value, what I can do is I can take the reciprocal of the right side. If I do it on the right side, I have to do it on the left side too. But what's in my denominator? Oh yeah, 3 is the same as 3 over 1. So I'm going to get 1/3 is equal to my b value. So my equation will be y equals 1/3 is my base. My a value is 1, so I didn't bother writing it in, all to the exponent x. And here's the equation for this second graph. At this point, I'll ask you to pause the video and try question number 11. Well, hopefully you finished number 11. Again, let's look at y-intercept. Now I'm here at 3. So I know my a value is equal to 3. So my equation will have the form y equals 3 times b to the exponent x. And then I'm going to look at where x is positive 1 or negative 1. Negative 1, I can't see it, it's off the grid. Positive 1, this point I can see, so my graph goes through 1 comma 1. So it gives me an xy ordered pair. I can plug in the y value is 1 when my x value is 1. So Now I want to solve for this b, so I'll undo that multiplying by 3, and I'll divide both sides of this equation by 3, which will give me b is equal to 1/3 again. So question 10 and 11 both have the same b value, but the graphs are different because they have different a values. So my equation here will be y equals 3 times 1/3 to the exponent x. And this will be the equation for graph number 11. All right, let's go down and look at some more information here. So here we're going to look at a constant, which is called Euler's constant. Now it looks like it's pronounced Euler, given the words up here, but actually the way this is pronounced is Euler, kind of like Edmonton Oilers. Okay? So Euler's constant is represented by an E, kind of like the number pi is represented with the Greek letter pi. Similar idea. Pi is to circles in geometry, E is to exponential functions. Let's grab this. There we go. Exponential functions. Just like pi, E is an irrational number. And approximately, if we put it in decimal form, it's 2.71828. If you look on your calculator, it may look like it repeats, but it doesn't actually repeat. There is no pattern. It is irrational. So the reason we need to look at E as a base is because once we get ahead and we look at exponential regressions, kind of like we did linear regressions, quadratic cubic regressions, sinusoidal regressions, we'll be doing exponential regressions. So our calculator will use E as the base when we do exponential regressions. I think, if I remember right. So just need to be familiar with it. Don't need to know much about it beyond that. So here, we're going to look at, again, an equation and then just describe some features of the graph based on that equation. So I'll go through this first column with you, and then I'll give you some time to do the second and third columns. And that finishes off this lesson. Okay, so let's go down and look at these features. So this equation that we're given here, the base is this number that has the exponent to it. Now notice this is not, doesn't have 5 and e as the base, only the e is the base. So this is the same as a 5 times e to the exponent x, like this. So notice the 5 not part of the base with that exponent. So the base is E Euler's constant. Is this graph increasing or decreasing? Well, Euler's constant, as we saw on the previous page, is approximately equal to 2.718. Is that what it was? I keep forgetting it. Let's have a quick glance back here. 2.718. Yep, that's about what it's equal to. That's bigger than 1, which means that our graph will be increasing as we go from left to right. So now that I have this little sketch here, that helps me describe the end behavior. So when I talk about the left end, I'm looking at this end of the graph, and it's approaching that horizontal asymptote of y equals 0. On the right end, the graph goes up forever, so we'd say it's approaching positive infinity as its y value. Now, when you look at your textbook, it's going to describe quadrants, but quadrants are pretty useless because our graph from left to right will always go from quadrant 2 to quadrant 1. That doesn't help describe the shape. So I would like you to describe which end is approaching the asymptote, in this case it's the left end, and which end is approaching infinity, going up forever, and in this case that's the right end. Next bit of information, the y-intercept. So y-intercept, again, as we've seen before, that's this a value. So the y-intercept is just 5. The domain for exponential functions, as we looked at before in the first lesson, is all real numbers. So x could be any number in that exponent. Similarly, the y will be y is greater than 0 as long as our a value is positive. So again, as we look at this little mini graph here, our graph comes close to the x-axis but never crosses it. So it never reaches a y value of 0. We say y equals 0 is a horizontal asymptote. That's just a guide to help us visualize it and understand it. All right, pause the video at this point, and you can fill in the next two columns, restart once you're done. Well, hopefully you've done these questions. So let me go through it. The base for this equation is the 7. Is the graph increasing or decreasing? Well, the base is bigger than 1, which means my graph will be increasing. The end behavior, well, again, because it's increasing, my graph will approach y equals 0, the asymptote on the left, and it'll approach infinity on the right. And I didn't drag this over before, but let's do that here. This is because the base is greater than 1, that it's approaching infinity on the right. That's giving us both sides of the end behavior. And my mouse has disappeared. There we go. Similarly here, because the base is approaching, I should say the base is greater than 1, that's why we're getting both of these end behaviors. What's the y-intercept for this equation? And we'll get a y-intercept of 0.5, which is that a value. And again, as before, our domain is all real numbers. Our range, y is greater than 0. Notice not equal to, just greater. And let's look at the last column. Here, my base, 0.8. Less than 1, bigger than 0. So that tells me that I have a decreasing exponential function. Since it's decreasing, my left end is approaching infinity, so the left end goes up forever, and my right end is approaching the horizontal asymptote. And again, the key for those two bits of information is that my base is between 0 and 1. The y-intercept this time is going to be 4, which is the a value. And again, same as before, domain is all real numbers, range y is greater than 0. And that finishes off this lesson. So there are questions at the bottom of the page, more practice from your textbook. Can't do this with a partner? Well, you can if you connect online. So questions 1 to 4, you should be able to do it. With a partner would be great if you can, and then these other questions you can try on your own. Make sure you highlight the questions that you aren't sure about so that you can ask about them in a future lesson. All right, thank you very much.